Tech Talk Tuesday's coming up quick. Time to tune in for Tech Talk Tuesday with George at Star. 6 o'clock sharp, we're going to start. John, how's it going, man? David, I'm going to try my best to keep this internet rolling. Hey, Sam. Hope it's going good with your new kid there. I see pictures of him on Facebook. That's really cool. Getting to be a dad and all that. That's nice. Charles, Howard. Thank you guys for tuning in. I have a different phone tonight. I have a new server in the showroom. It's supposedly a 5G deal. Hey, Larry, John. Testing 1, 2, 3 test. Charlie. Yeah, it's good. I guess my phone, the phone I use is a good phone. I think it's like an iPhone 10 or 30 or something, but it's not really old. But, it seems like they have an expiration date on them. Daryl, Sam again. Eric, yeah, that's great. I'm glad he's doing good. But, those phones, the one I've had about 10 in a row, and they seem to only last for a certain amount of time. And it's like they have like a gas tank, they just run out of gas. And they keep working, but it's not as sharp. And I'm not talking about the picture, I'm not talking about the speed. I'm talking about, like, it just doesn't cooperate. Like, you can hit a button 3 times before to go, or it seems like it loses its feel. But anyway, I have Jackie's phone here, and if this works better, we signed up. Hey, Mike, Zachary, we signed up. Richard, what's up, my friend? Richard. That's Dory Daddy right there. John, yeah. So what was good, all the way from Finglish over there, Yaska Salakari. What a cool name. Hello, my name is Yaska Salakari. I am from Finglish. No, I speak Finglish. I'm from Finland. Ian. Wow, Ian Mopar. Yeah, you must know Yaska if you said time bomb. Wayne. Wow, look, you from over there too, man. That's across the ocean. What time is it over there, man? It's got to be midnight by now, you guys. Time to go to bed. Michael, my buddy. Bill, Papard. Man, that's a blast from the past. Anyway, I wrote some numbers down here, and we're going to talk a little bit about some of the engines that are available that we work on. And I'm going to put a little name by them here. This one is the twin cam. This one is the S&S T143. I forgot to write that. And this one is the M8. Now, what's interesting about this stuff that I just wrote down, let me see if I can get you all on the screen. Yaska 102. That sounds like a good 60 foot. Maybe not for you. Hey, Jerry. Steve Lowry, Ian Mopar. 8 here. Woo! Like tomorrow. It's 8 o'clock tomorrow, right? That's hard for a farm boy from Georgia to be able to say. It's already 8 a.m. tomorrow. Makes me feel like I'm in some kind of Back to the Future movie. Hey, Steve. Yaska, no. There's Julie. That's Tyler Bennett's wife. He had a birthday this week. She had a birthday last week. How y'all? Magnet interface with the sunspot. Oh, okay. That makes sense. Now I understand. Okay, it's after 6 now, so I can go ahead and start talking a little bit about it. This is a print from the head gasket manufacturer of the twin cam head gasket. And the bolt-to-bolt measurement's 3,180 across here and 3.738 here. Believe it or not, y'all, these numbers is what dictates how big of a bore you can have. If these studs were all moved out in the cases and the dowel pins were moved out in the cases, we could put a bigger bore in it. So this is our bore limit, the stud pattern. Then if you go over to the S&S, they did a great job. They took the twin cam and stepped that baby up from a 3,180 to a 3,320 between the bolts, and from a 3,738 they went to a 4,066. They moved these bolts apart, and that allowed this to go up all the way to a 4.4 bore and still have room for the head gaskets here, okay? Now, I see guys with some of these twin cams, they put 131 kits on the stock cases, and when you bore out this all the way out to the dowel pins, and you bore it all the way out to the cylinder studs, there's no room for a head gasket to get in here. And I'm gonna draw a little baby picture here, because when you bore it out as big as it go, you've got a bore that goes right there. And I promise you it's gonna leak. So 131s in a twin cam are not my favorite, because when you're running it down the road and you're wide open throttle, the studs are getting longer and it's trying to blow the head off of the top of the engine, and the head gasket has to be able to move in there a little bit. And as these studs stretch, you get compression leaks by, and you want to have a really nice area to clamp to. Chris, Michael, Rob, how y'all doing? So what my point is here is, like with this one here, you want to be able to keep the bore inside of the dowel pins, inside of the dowel pins. A man could move his dowel pins. You could move the dowel pins over in your cylinders. You could move the dowel pins over in your head, and that wouldn't be a problem. But the real problem is you got to have room here. Now, Harley Davidson watched all of us guys and girls with these hot rod Harley engines. They watched us flop around for decades trying to make more cubic inches, more stroke, more bore. And when they came out with the Milwaukee-Eight, they blew us away. From a twin cam, a 3.180 center to center, they went to 3.870. And from a 3.730, they went 4.270. So the Milwaukee-Eight stock Harley bolt pattern allows us to use bores bigger than the S&S engine. The bores in a stock Milwaukee-Eight, the head bolt pattern, the cylinder stud pattern, the dowel pin location, the head bolt locations are so far apart and so spread out that a man can put bigger than a 4.5 bore in a Milwaukee-Eight with the stock cases, the stock head, the stock cylinders. So we have 150 cubic inch and bigger Milwaukee-Eights running with stock cases, stock cylinders, and stock heads. Now, yes, the cases are bored out. Yes, the cylinders are bored out. Yes, they are. But it's still, if you see a 150, 160 cubic inch Milwaukee-Eight engine running around, it doesn't have aftermarket cases. It doesn't have aftermarket cylinders. It doesn't have B2 heads or S&S heads or Patrick heads or whatever, all those aftermarket and companies that sell heads. They're all stock. So right now, the market there's not going to be a lot of this stuff for sale bigger than that, because Harley did it already. Will we ever stop making more cubic inches? No, we'll always make more cubic inches. Hey, Steve. Hey, Enos. I don't know if you guys, Craig. Yeah, there you go. That's the horsepower man right there. He's got boost in his name. Yep. 1,000 horsepower right there. Snowmobiles. Going to the Milwaukee-Eight. You can put a 4.55 bore in it. Then you can buy S&S makes some cranks. They sell them every day for 4.625. And you can make a 150 cubic inch engine out of it. The stock crank that comes in the Milwaukee-Eight and a CVO and a 114 is a 4.5 stroke. The big twin cams, the 96, the 103, the 110s, they come with 4.375. The Milwaukee-Eight 107s come with exactly the same stroke, 4.375. But instead of having a maximum bore with bored cases of a 4.145, a Milwaukee-Eight can go 4.550. So look at how much more bore because of the bolt patterns. Remember me showing you guys? The bolt pattern, how far apart the bolts are, gives us the chance to put a giant bore in with this package. All right. The S&S T143 is a really nice piece. You can put a 4.470 bore in it and a 4.6. They come with a 4.625 crank. That would make 145 cubes. That's a really nice engine. Comes with a set of B3 heads, which is a really short B2 head. It's about 300 to 400,000 shorter, so it'll fit in a stock frame without modifying, and that limits how much horsepower we can make because we don't get enough air in the engine. But anyway, I was very thankful to get these prints. I could have measured them all out, but this saved us a lot of time. The Pro Stock, our pro stock NHRA that I raced for years with S&S was a 5. The last one we did was a 5.140 bore with a 3.7, nope, maybe 3.8. I think it was something like that, 3.8. Anyway, it came out to 160 cubic inches. But the 160 cubic inches was done with giant bore, short stroke, lots of RPM. And the bore, the bigger the bore, the bigger we can put valves in it. So twin cam is limited on valve size. Even with our B2 heads on this stud pattern right here, you can buy B2 heads from S&S that will fit in this twin cam head gasket. But you have to keep the bore down around 4140, 4135, 4145. So you can keep a good head gasket and a good base gasket. If any of you guys have ever had a Harley twin cam with a 131 or 127, 128 or 124 and you're having some base gasket leaks and you can't keep oil from coming through the breathers, the air cleaner and stuff, it's because we're losing ring seal, and that blow-by is because of the rings leaking and letting the crankcase, the combustion pressure leak by the rings and go into the cases, and then of course it spills out of the breathers. And good ring seal and good gaskets really make up a big difference there. Now, if you can actually have a really big engine with little thin gaskets that don't have much room here, if your rings are sealed up nice, there's not enough blow-by or leakage by the rings in order to create pressure here. So that's also part of the equation. If you have a lot of pressure in the bottom end, it doesn't matter really how good your gaskets are, it's going to leak anyway. Hey, what's up, Ron? Okay, talking about bigger valves, let's jump over here for a minute to some flow bench stuff. Because there are people now, you can buy flow benches. You can buy like Superflow 110, you can buy a Superflow 600, I forgot the next size, and then they got the 1020. We used the 1020. We got one of the first ones when they first came out, and their biggest claim to fame with that was we can run 50 inches of depression test, which means it's got a lot of vacuum cleaners in it to pull air through the port. Now, why that's interesting, y'all, is back when we first started racing, back when pro stock bikes had wooden wheels, Mike Keat and I and Terry Vance and Byron, we used to race back. There wasn't even anything really cool. They were cool back then, but we didn't know any better. But the biggest flow bench a man could really work with was the 10-inch flow bench, and I think Superflow called it the 110. And the 110, we tested it at 1 inch. And at 10 inches. And if you wanted to run more than 10 inches, you better have a port that doesn't flow very much, because if it flowed a lot of air, then it would run out of bench. In other words, it couldn't pull a depression on it. Like this 50-inch bench, this 1020, the Superflow 1020, is a big flow bench. Okay. At 50 inches on this S&S Pro Stock engine, it's hard to get 50 inches of depression across that at 1 inch lift, 1 inch 200 lift. Yeah, that's right, 200 lift. That's a lot of lift. But it'll pull, at 28 inches, the 1020 will pull 600 CFM easy. At 50 inches, it'll pull probably 700 or 800 CFM. So you gotta have a massive flow bench to show 700 or 800 CFM. Why is that important? Well, and I'm not bagging on anybody, and these are my opinions, okay? I promise you I'm not, because I'm very fortunate to be able to have the equipment that we have. But I tell you what, we have made payments for 40 years, and I'm still not done making payments. So when I brag, or you think I'm bragging about the equipment we have, and the Superflow engine dyno, and the DTS engine dyno, and the dyno jet chassis dyno, and the boring and honing equipment, and all the cool stuff that a complete shop has, it comes with a serious price. So just your average guy that works on your Harley for you, or your mechanic guy, your engine builder guy, a lot of them don't have a lot of equipment. But we started off as a full service engine machine shop, and kind of morphed into how to make all kind of engines go fast. But the 10 inch You can learn a lot with that. I had a really smart guy talk to on the phone today, and he and I were just covering these bases, and he said the words, you can learn a lot with a 10-inch flow bench. They don't cost a lot of money. You can find them used, but you can't move much air. And I want you to think about how much air is moving in a Milwaukee-Eight at full song when it's going peak 6,000 RPM. It's got a 4.5 bore and a 4.5 stroke. At 6,000 RPM, I'm telling you, that thing, there's a bunch of air going in that engine. Now, at 10 inches, you could flow it, and it would tell you 200 CFM maybe. If you flowed that same head at 28 inches, there's a math equation that'll tell you what, if it flows this at 10, it will flow this at 28. If it flows this at 28, it will flow this at 50. There's math. But listen to me, y'all. It doesn't know really what the head will flow. It tells you what it would flow as far as math. But if you can flow all the heads at 50 inches, which is not a published, that's not like a published deal. People don't brag on what your heads flow at 50 inches. They don't brag on that. I would use 50 inches as a development pressure to test the heads, because if you see a little change in the flow numbers and you got a flow graph that looks kind of like this, at 50 inches, you may see the highs and lows where it wouldn't be as defined if you floated only at 28 inches. You will find the weak spots, the strong spots, flows a little bit better, a little bit worse at each lift. Let me tell you what the flow bench does. You put the head on the flow bench, okay? And you have an intake valve and you have an exhaust valve. So intake valve's here. And the valve goes up, and you put a little checking spring on it, and then you put a dial indicator here, and you measure how far this valve is open, and you turn on the flow bench and it pulls depression this way. So you put a little velocity stack or air cleaner or throttle body on here, and the air comes through here, and you check it at 28 inches. So you set it at 100 lift, you adjust the power to 28 inches, and then you record that number, whatever it flows, say 100 CFM. And then you make this open more to 200, adjust this to 28 inches, and then it flows, say, 150. And you do that on and on and on and on. Now, if you're trying to just see a number, what the head flows, I watch it on the internet just like you guys do. People say, what do your heads flow? Well, listen, the heads flow 100 CFM, 200 CFM, 400 CFM. Same head. At 300 lift, this one would flow maybe 75, this one would flow about 150, this one would maybe flow 300. Open the valve to 500 lift, same head, same flow bench, set it at 10 inches, might flow 200. At 28 inches, it might flow 300, and at 50 inches, it might flow 500. So when you ask me, what does a head flow? And then I say, at what lift and what depression, people think that I'm being a smart butt. But it's a fair question, you guys. What lift, what depression? Also, we found over time that if you got the valve size right for the bore that you're running, and you got the valve size right, you got all the intake and all the exhaust you can get in it, and you got the port working great, you can flow it. That'd be great, but that's not the bottom line. It needs to look like this, in my opinion. That's what it needs to look like. Okay, sure, we can't do that. We got to bend it. We got to bend it over here, and then you got to put the throttle body over here, and then you got to put your little horn on it, and then you got to put your little, then you got to hang a backing plate and an air filter on it. Now, this is called packaging. I'll tell you a real quick story. I got a friend that worked Ford Motor Company for years, and he ran a shop for Ford Motor Company, had 30 dynos, and he was telling me about 30 years ago, he's telling me about this new 5-liter V8. I think it was a 4-inch by 3-inch bore and stroke. And he said they put this thing together in the Ford dyno shop with OE parts, and they made 600 horsepower with it. And they were so excited, and they put them on all these dynos, and they ran them forever and forever and forever. And he said they handed it off to the packaging engineers, and the first thing they did is they noticed that the way the engine looked, the V8 engine, it had really nice headers on it, and it had these really nice stacks on it. And they put it in a car, and you couldn't put front tires on it or fenders because the headers were in the way, and they couldn't shut the hood because of the intake system. So they made the intake system fit the car, and they made the exhaust fit the car, and they made a manifold that had the roly-poly intake ports in it, and they got it finished, and they shut the hood, and it made 300 horsepower, same engine. That's because of the packaging problems that we run into. But the S&S Pro Stock engine that the guys up in Wisconsin developed, they built a perfect dyno engine. It was like, they made a V-twin. Like I said, it had a 5 1/8 bore. It had the front cylinder stood up like that, and the back cylinder was back this. And they leaned this engine back. They had the engine rotated backwards so that when we put it in a Pro Stock bike frame, this would actually be the cylinder head was, the neck of the frame, okay? Where you put the forks on here. And we had the intake ports coming out like this. So we had to build a frame to fit this, and with this neck of the what's it called? The fork neck, the head for the forks. Forgot what you call it. Where the triple trees go on. Was so close to the cylinder head that we had to make special tools to check the exhaust valve spring, to change the exhaust valve spring because of the packaging problems. Then we had to build a body that would give this airbox room for this to breathe in and out. And then, of course, the exhaust system really had to be funky to fit the motorcycle because they have rules about all that stuff. Well, what was neat about this engine was it made the most power on the dyno. It really, really was an astounding piece. And then when they got finished with it, then they handed it off to us race guys and said, okay, put this in your bike. Well, it didn't take us long to figure out there was a new motorcycle required. And they knew that. They knew it was going to take steering neck. Thank you, my Finglish friend. And David Sickle says, I'm breaking up. Wow, I'm so sorry, man. Steering head. Thank you all for that. I know I flopped around like a fish out of water a little bit, but we'll recover. But back to the story, what I was going to say is what we found was a new motorcycle was required. So Cosman Specialties and Martin Windmill and all of us guys here at Star, we came up with a really great design to put the engine in and build a frame around the engine and put the steering head as close as we could so the engine would be as far forward so we would be front heavy. And I try and do a really quick sketch. We had a front wheel and a back wheel, and these things had to be 70 inches apart, and then they had to have a steering head angle that mattered, and then the engine had to be 2 inches off the ground, and you wanted to weight as far forward as you could get it. So we kept moving the engine forward until it ran into the steering neck. Head stop, whatever. That's good. So the packaging is very, very important. Why is that important on the Harley guys right now? Okay, we have a new Milwaukee-Eight. It's a really nice engine. It's 45-degree V-twin. It's a really nice piece. And in order for us to get it in the motorcycle, we have a backbone that comes right across here. And we want to have a really nice intake system for the manifold and the throttle body here and for the ports to go here. And of course the exhaust goes out like this. I'm sorry I'm drawing too fast. But if you turn this and look at it from the front view, your engine's here, and the head's here, and this manifold is back here, and this is all good, but when you build the intake, it has to come off and turn down here This is looking at it from the front where the exhaust pipe would come out here. And then they put the throttle body down here. Why did they do that? It's because the gas tank fits on here. That big old 6-gallon gas tank. Looking at it from the front. So the throttle body is under the gas tank, even though the manifold is higher up. So the intake system, looking at it from the front or looking at it from the side, is very contortionary. The air has to come in, it has to go up this hill, it has to make these turns, go front to rear. And EFI was a savior for that, because carburetor sitting in that position doesn't like, for the fuel doesn't like to turn all those corners from a carburetor. But the fuel injection doesn't mind, because we spray on the intake manifold, we spray the injectors. Here's the throttle body. We spray the injectors right on the back of the intake valve. So we get 40, 50 PSI right on the back of the valve, and the air has to do all these shenanigans. And the air doesn't mind bending around these corners, but boy, oh boy, that fuel does not want to turn. All right, that was a lot to talk about. Dyno sheets. I had a little competition or a little story going on the other day that was interesting with some guys on the internet about dyno sheets. And I was talking about how can you make 160 horsepower on a big V-twin and not spark knock, because we're all saddled with gasoline. And that reminds me to go back to this story over here before we do this dyno sheet. I want to look at this. Us Harley mechanics, the guys that got into this years ago, this was a new engine for us. Twin cam was a new engine. The Evo was the one before that. And of course, way before that, there were shovel heads and pan heads and knuckle heads. And I was a knucklehead for all those years. But the twin cam taught us a lot. And we were able to build a 117 cubic inch engine with all the stock parts. By boring the cases, putting sleeves, getting kits, we could make a 117. Well, we're not going to make 160 foot-pounds of torque or 160 horsepower with a 117, because I'm not going to say it's impossible, but it doesn't happen very often. Some superstar engine hero guy could build 160 horsepower 117, normally aspirated, but he wouldn't do it on 93 octane pump gas. Then the T143 came out, and yes, S&S sells them every day, but if you call them up and say, hey, I want to put a touring bike together, and I want to drive across the country. I want to go to Sturgis and Daytona and California and back. And I want to buy a T143 because I want 165 horsepower and I want to run on 91 octane gas. This is an oxymoron right here. 165 horse, 165 foot-pounds on 91 octane. This engine can do it. It can make this much power. But that is so much cylinder pressure, because look, I didn't get to do this the other day, but this is where it gets a little bit complicated, and I'm jumping around like a crazy man. But this is what cylinder pressure looks like, okay? You can't make more power without more cylinder pressure. This is a little 130 horsepower engine. That's the cylinder pressure it would take, just for comparison purposes, to make 130 horsepower. Here's a 150 horsepower one, okay? Here's a 160 horsepower, and then here's a 180 horsepower, all right? Which one of these, 180, 160, 130, 100, whatever, which one of these makes the most cylinder pressure? Well, it's this one. And the reason it makes more cylinder, well, that's why it has more power. Look, you got to have cylinder pressure make power. So if you don't want to increase cylinder pressure, you're not going to make more power. That's my opinion. That's George Bryce's opinion. When you make more power, you make more cylinder pressure. Now, gasoline ignites based on pressure, heat, and spark. So if you squeeze it to 160 or 180 horse, and you heat it up by driving at 100 miles an hour down the highway or sitting in traffic at Daytona, parade traffic, and then you try to spark it at 25 degrees before top dead center, one of these is going to outdo the other. And it's going to light off before it's supposed to. And when it lights off before it's supposed to, this is what the cylinder pressure would look like. This is detonation, spark knock. So how do you eliminate that? Well, the only way I know how to eliminate it is increase the octane, get more of it, cool it more, which means no parades. Don't carry all the heavy people and all the baggage and pull a trailer with a 143. Sorry, I'm not thinking that's possible. Yeah, you've done it. I know you've done it, but was it the right thing to do? No. And then you got to turn the spark down. You got to run the timing really low. Less spark. How do you cool it? Well, oil coolers cool it a little bit, but about 10 degrees. But the way you cool it is you put it out in the road and you let the wind blow on it with the pressure turned down. And here's the pressure control. It's right here. This is low pressure. This is big pressure. So if your cylinder wall, if you could see it going down the road, this is how it would look with the throttle off. And if you turn the throttle on, this is how the cylinder would look. It's trying to blow apart. It's trying to blow the sides out. It's trying to blow the piston through the side, and it's trying to blow the head off. This is the pressure. Now, the only way we can live with that is for the spark plug to light off at the right time. And when the spark plug lights off at the right time, easy for you to say, when the spark plug lights off, that means we can control this detonation curve, this pressure curve. We can control it. If the spark lights off before, if the gas lights off before the spark lights, you're going to have uncontrolled combustion and uncontrolled cylinder pressure, and you're going to have a lot of broken parts. So this engine trained all of us how to build the most powerful engine. That was close, almost crashed. It's hard to crash on Tech Talk Tuesday in the air conditioner. 117 cubes. We could make that a radical engine, and it would never make enough pressure for us to screw up with the gasoline or run hot. Then these 143s came out years and years ago. 143s came out, and S&S was selling. Please don't put it in your touring bike. These are for hot rod bikes. They're not for touring. Well, people put them in and used them anyway. But what happened is we detonated a lot. We had a lot of blow-by. We had a lot of rings leaking, and we had trouble with these. And these need octane. Okay, because if you turn the spark timing down where they won't spark knock with 91 octane, it runs really hot, and that makes it wear out sooner. Because the lower the timing, the hotter the cylinder head is. The higher the timing, as long as you're not spark knocking or detonating, the lower temperature the cylinder head has. It's been proven 100 times, and of course it's just an opinion. Now, Milwaukee-Eight came out with all these dimensional capabilities. That's a big word for a Georgia boy. Dimensional capabilities, where you got a big studs that are far apart this way and this way, and you can put big bores, big strokes, and big cubic inches. And now all of us engine dummies outran the gasoline. Everybody in America that I read on the internet every night, these guys right here, they build these giant, they build 128s. Let's go over here. 128s. They build 128s. They build 131s. They build 143s. Back when they didn't even know why a 117 ran good 20 years ago or 7 years ago. 117 ran good. But there wasn't enough cylinder pressure here to get the engine builder in trouble or the motorcycle owner. Now you can buy these parts from Harley, Screaming Eagle Stage 5s and Stage 12s, and you can get all these cubic inches, and you can outrun the gasoline. Everybody watching Tech Talk Tuesday tonight can outrun the gasoline. So the Milwaukee-Eight has created a monster in engine builders and capabilities, because this is the first Harley engine available from Harley that can make enough cylinder pressure to wreck parts by having too much pressure. And the gasoline will pre-ignite, self-ignite. I think it's called premature combustion, detonation. There's lots of terms for it. So this has given us new trouble. So my question was, how can I make 160 foot-pounds with an M8 or a twin cam and sell it to a customer that he can run it cross-country, do touring, and run it on 91 octane on a normally aspirated engine, not a turbo, not an intercooled turbo, not a supercharger with intercoolers. Intercoolers are good. Intercoolers turn down that temperature. So your intake temperature and cylinder pressure gives you a chance to outrun the 91 octane, okay? Car motors, motorcycle engines, truck engines, it doesn't matter. Same story, we all use the same gasoline. So 160 foot-pounds on a Milwaukee-Eight with 91 octane, and the guy wants us to stand behind it. He wants me to be responsible for, does it sunk going down the road? Does it spark knock? I got to have octane boost. I don't need racing gas. Well, George Bryce at Star Racing Power right now, we will sell you a 150 foot-pound engine if you're going to run 91 octane. That's what we sell. Now, my competitors that are watching this and they're trying to outsell me and they're trying to outdo me, they promise 200, they promise 190, they promise 180. We can do it. They already did it. But look, it doesn't hold up with 91 octane. Now, if you can do it, then I'm going to say you're the man. I hadn't figured out how yet, and I'm going to use yet as a very important word, because there is a way to build timing curves, and there is a way to use cam timing to bleed some of this pressure off at the places where you have spark knock. We gotta have too much cam timing to bleed some cylinder pressure off. We gotta have really low ignition timing at high manifold pressure, 100 kPa at 2,000 RPM at part throttle. Say that again. 100 kPa at 2,000 RPM at part throttle makes you spark knock like crazy, especially when you're all the way up to 300 degrees operating temperature. So I got challenged on the internet, on Facebook or whatever, and people were saying, Hayabusa would do it, a ZX14 would do it, a BMW would do it. They all make that much power. But look, I'm going to tell you, they don't make 150, 160 foot-pounds of torque. Yeah, they make 200 horsepower. Here's a Busa, stock Busa, 178 at the tire, 107 foot-pounds. Okay? Here, it's got a kit in it. It's got a jet kit and a pipe, maybe a tuner, maybe some trick gasoline, and they got it up to 200 horsepower and 115 foot-pounds of torque. So a Harley you can't do it with a Harley, because at 150 it spark knocks on 91, but this will run on 91, and let me tell you why. The Harley runs from 2,000, let's say, from 2,000 RPM, torque curve looks like this. And the horsepower curve looks like this. So if we make 160 here and 150 here, 150 foot-pounds and 160 horsepower, this is what it would look like on top of a Busa, okay? But look what the Busa makes. At peak torque here at 4,500, the Busa makes 90 foot-pounds, and the Harley makes 150 foot-pounds. That's why they're so much fun to ride. We're not talking about which bike is better, but I'm just telling you, if you say you got a 200 horsepower Busa, yeah, overlay my horsepower curve on top of it and look at it. If you did a high gear roll on with this guy or this guy, with this guy, you're going to get beat, because you got to get this, in order to get up to 160, you got to get this engine up to 8,000 RPM. You have to go 8,000 to catch the Harley. So when you shift the bike at 11,000, you're going to outrun it bad. Yeah, you're going to go 11,000, 8, 11, 8, 11, 8. You're going to stay in this range. That's why Harleys don't run with Busas. But don't tell me why your Busa can make more power with 91 octane than the Harley can with 91 octane, because it doesn't make close to the same power. 4,000 RPM, our Thrasher kits make, what's that, 50 more foot-pounds at 4,000 RPM. Anyway, that's another whole story. That's an answer, an argument, question, whatever. I appreciate you guys watching. I went overtime here. Wanted to tell y'all, thank y'all very much. Take care of each other. Please ask me questions. I was talking really fast. I'm thankful for you all tuning in. Send me questions. Give me comments, and email me, george@starracing.com, or message me on my Facebook page, George Bryce. And of course, look around at the Star Power page. We got a lot of interesting stuff we post up all the time. And I'm an engine guy. I'm just an engine guy, and I love engines, and I'm very thankful to get to work on these engines and learn more about it, and I'm learning really fast. So these are my opinions, and I'm not trying to argue. So But I would love to hear what you have to say. Thank you.